Hello and welcome to a new calculator tutorial for the TI-84 Plus. Today we'll be discussing permutations and combinations in the TI calculator, which honestly is not too much. So I'm going to go a little deeper into how you might be able to look at a distribution of permutations and combinations. Because once you know how to use the permutation and combinations formula, you won't forget it. So, permutations and combinations. What we're doing in these cases is that we have some amount of objects and we're picking some amount of them to put in order or to put into some selection. For example, my car is relatively old and I use a 6 CD changer, which means that I can have at any one time 6 CDs in my car to play music. But I have quite a few CDs other than that. So say, for example, I have 10 CDs that I really like to listen to, but I can only choose 6 of them to put into my car. That means that we're either using a permutation or a combination to determine how many different ways I could choose those 6 out of 10 objects. The difference being with permutations is that the order matters. So maybe the first CD in my car is the most important one, so it does matter which one is selected first and which one is selected second. If it is arbitrary, then it's called a combination. It's just combining some amount of objects together. The way that they're put in there doesn't really matter. So that's the difference here. Now to access both of them, we're going to be going into math. However, what we first need to realize before we get to that function are the two values that we need to know. The two numbers that we need are, one, the number of objects, so the total number of objects we're choosing from, we are going to call that n, and the number of objects that we are choosing, or the amount of objects we're going to be taking from that total. So if I'm choosing 10 for my total, then I'm choosing 6 out of those 10. Those 6 would be my R value. So I need to know N, which is the total number of objects, and R, which is the total chosen number of objects. Okay, once I know those, I'm going to need to plug it in specifically. Now I'll show you where the program is so you can see what it looks like. If you hit math, it's going to be in the probability function where rand was, if you saw a previous video. And we're going to be using these three, 2, 3, and 4. 2 is going to be for permutations, hence P. 3 is going to be for combinations. And 4 is going to be just if you're doing a standard factorial. Probably won't be using that, but you may need to use it if you're doing permutations of non-distinct objects. Then you might need to make your own formula. But if you're doing distinct objects, we'll be sticking to NPR and NCR. Now, notice that it has N before the permutation and R afterwards. This is going to tell you how you actually use this formula. This means that you need to actually type in the N value first before you go and fetch this program. It's not going to be like the others, like randint, that asks you to put prompts in afterward, or binomial that asks you to put prompts in afterward, or oneverstats that asks you to put prompt in afterward. This is going to be different. We need to put the total number in first. So I'm going to go back to my main screen by quitting back. And in this case, again, I'm going to be using my CD example. I have 10 CDs and I'm taking 6 of them. If the order matters, I'll be doing a permutation. So I have 10 CDs. And then I'm going to go to math. And I'm going to get my permutation function, which again is in probability. Once I hit NPR, it pastes in and look at that. It takes 10 and it puts it in as a pre-subscript, indicating that it took the place of N, which is my total amount. Then I'm selecting 6 of them, so I put 6 into here. And this is all I need for the function. If you're using an 83 or an older version of 84, this may look different. What it would look like is 10, and then it would just say NPR, and then you type in the number 6. So the prompting would look a little bit different, but we work with it the exact same. Regardless, once I have this in, I have 10 overall objects and taking 6 of them, and the order matters here. I hit enter, and this says that there's 151,200 different ways I can order 6 of those 10 objects, if the order does matter, which is a heck of a lot. But that's to be expected with permutations and combinations. The more and more that you use, the higher and higher it gets, at least for permutations. Now, if I'm doing the combination, if I just need to select 6 of those CDs, and it doesn't matter the order that they're put into my car, then I can just do 10C6, or 10 choose 6 is how we tend to read that. And I'll be working with it the same way. So I plug in 10 first, I go over to math, I'm going to go over to probability, and I'm going to fetch NCR. So now this is 10C6, so 10 choose 6 is how we tend to read this. And now this says there's only 210 ways. This is showing how drastic the order can matter and the number of ways things can be done. If the order matters, there's 151,000 ways. If the order does not matter, a lot of those ways are repeated. So maybe I just swap the first and second CD, but it would be the same collection of 6 CDs. That's what combinations takes out, any of those repeated. So this is just showing that there's 210 ways to take 6 of those CDs if I don't care about the order they are placed. Alright, so that's permutations and combinations. Now this might be all you need to know, but let's look a little bit deeper into this and see how permutations and combinations actually act. To do this, I'm going to go into a list. Now using my same example, I'm going to be choosing some amount of my CDs to select of my overall 10. So I'm going to populate my list 1 with the values 0 up through 10, because those are the number of CDs I could possibly choose out of 10. I could choose none of them, I could choose 10 of them, but I could choose anything in between, and I could find out the number of ways I can order those. So this is going to be the number of CDs chosen. So I'm going to go over to L2, again making sure that L2 is highlighted, not the first line of it. So it says L2 equals. And I'm going to be using the same prompt as before. 10. Going to go over to permutations and PR. And instead of putting a number here, because now I'm overall of 10 objects, how many am I choosing? I'm choosing one of these values that I have in list 1. So in this case, it's going to be 10P, and I'm going to put in second 1. So now this will calculate 10 permutate 1, 10 permutate 2, 10 permutate 3, etc., etc. It'll find all these values for me once I hit enter here. And there we go, we get a lot of them, including the value that we had for 6 earlier of 151,000. This is showing that there's only one way to select 0 of the objects. There's 10 ways to select one of them, which makes sense. I could just choose any one of those 10 CDs, and that would be a different ordering. But once I go deeper and deeper, it gets more and more and more, to the point that it gets very high. But look at the last one. It says 3.63 E6, which means 3.63 times 10 to the 6th, or, as it shows down here, 3,628,800, which is a lot of different ways. If I take all 10 CDs, there's that many ways to order them. Now again, this is if order matters. And notice that the number of ways just keeps increasing because I have more and more objects I am choosing to put in order. If it doesn't matter about the order, then it's going to make a different shape than this. This is just an ever increasing amount. But if I don't care about the order, let's look at what happens there. So again, if I don't care about the order, that's going to be a combination. So 10, I'm going to use NCR here. And again, I'm going to choose the values from list 1. So 10, choose some number from list 1. So 10, choose 0, 10, choose 1, etc., etc. If I press enter on that, look what happens here. This comes out to be more of a normalized curve, depending on where you are in statistics, I guess. Here, there's one way to choose none of them, because I could just choose a 0 amount of CDs. But there's also only one way to choose all 10, because in this case, the order doesn't matter. So those 3 million different ways we had before for permutations, those were all repeated ways. They were just shuffled around. Combinations don't care about that, so there's so much less. The most amount of ways you could get anything with a combination is smack dab in the middle here with 5. If I choose 5 of the CDs, there's 252 ways if I don't care about the order. But then from 5 on, it increases and decreases down. Similar to how if you look at rolls of dice, the probability of getting, if you roll 2 dice, the probability of getting a 7 is very likely compared to the rest. But when you deviate away from 7, it becomes increasingly unlikely. Same concept here. 5 is the most amount of ways has the most amount of ways I can combine objects, but once I go away from that, I get less and less different combinations I could possibly create. So this is showing the inherent differences between permutations and combinations and how they act when looking at a lot of different values. With that said, that's everything that you'll probably need to know for permutations and combinations in the calculator, at least up to this point. They're incredibly important for a lot of different distribution functions where we do permutations and combinations, particularly combinations, to solve things. For example, binomial probabilities use combinations in its overall formula. Not in the calculator already does that, but it leads into a lot of other circumstances where you're trying to choose a lot of different objects or see how a lot of different ways can occur. And very often we're working with combinations. But very often what you'll do here is just the stuff that we had on the main screen. So understanding 10p6, 10c6, and how that works. You'll get errors if you try to throw it the other way around. If you try to do 6, choose 10, that won't make sense because it's trying to say that there's only 6 overall objects, so how can you choose 10 of them? The first number should always be the greatest. It should be the overall total. But yeah, work with a couple of these. You'll get the hang of it very quick because they work the same and they're pretty logical. So no big issues there or a lot of hiccups that people run into. But if you do have any questions, if there are any concerns you have, please feel free to put any comments in the comment section below. Or if you're one of my students, feel free to just come up and ask me the question. But with that said, I will see you in another statistics video.